So, we have a continuous beam with maximum moment capacity mu. We are going to find 3 collapse mechanisms and then 3 collapse loads and see which collapse load is the smallest one, because that's going to be our true collapse load. So, let's start from segment A to B. We're going to have to find the angles. So let's say this one is theta. We know it's symmetrical, so this one will also be theta. And we need the external angle, which is going to be the sum of the 2 internal angles, so 2 theta. Now, to find the external work, we are going to multiply the force of 5p by the displacement, basically distance, and we're going to call that delta x. So to find this, we're going to use tan of the opposite, which is dx, over the adjacent, which is L. So let's write this here. Tan theta is dx, basically this length, dx, over L. We're assuming small angle approximations, so now we can simply rearrange in terms of dx being theta L. So this length is theta L. Now we can find the external work, so the force 5p times displacement theta L, we get 5p L theta. Now for the internal work, we have to take into account the moment contributions from each plastic hinge. We have a plastic hinge here, and a real hinge here. So this means, you can see from here, that the moment at point A is 0. So there's no moment contribution for our internal work, only from the plastic hinges, not from the real hinge. And the moment contribution from the plastic hinges is mu and mu. So internal work is mu times theta plus mu times 2 theta. So that's going to be 3 mu theta. Now, when you equate these, the internal and external work, because you know they're equal, you get 5p and theta is 3 mu theta. Cancel out theta, and we're going to rearrange to find p, so the collapse load between points A and B. So 3 mu over 5L, so 0.6 mu over L. Now, on to the next segment, so BC. Once again, we're going to start off by finding the angles, but in this case, they're not symmetrical anymore. I mean, they're not going to be equal. So let's assume this angle is theta, and let's call this one phi. We're going to find phi in terms of theta. And to do that, we're going to need to know, because we're using tan again, what this length is. We're also going to need it when we're finding our external moment. So tan theta is going to be opposite, so this length, which we know is dx, that's what we're going to call it, this over the length of 2L. Assuming small angle approximations, so just get rid of tan, and rearrange in terms of dx, you get 2L theta as this displacement, 2L theta of 5p. So now we can find phi in terms of theta. So tan phi is going to be 2L theta over L. Small angle approximations, so get rid of tan, cancel out the L's, so you get that phi is 2 theta. Now we can write in here 2 theta. Now we're going to find the external work, so the force times the distance, the force due to the load, 2L theta, 10 PL theta. And the internal work, so now let's sum up the moment contributions at the plastic hinges. How many plastic hinges do we have? 3. All 3 of them are plastic hinges. None of them are real hinges anymore. Basically just A is a real hinge. You're going to see when we get onto this one, it's also a plastic hinge, because like it has moment contribution. So MU here, MU here, MU here. We're going to add up for the internal work 2 MU theta plus MU times by, this is going to be 3 theta, plus MU theta. So we're going to have 6 MU theta. When we equate the internal and external work, you get, cancel out theta, and rearrange for the collapse load P between B and C. 10L. So this is 0.6 MU over L. It's the same as this one. Now, last one. You can just see that the angles are going to be 2, just theta and 2 theta, because we have 2L, L, L, 2L. So theta, 2 theta, 2 theta, theta, basically symmetry. But, to be safe, use tan again. And this length, displacement 2L theta. Now, external work, this time we have a point load of 4P times by displacement 2L theta, so 8PL theta. And the internal work, we have 3 plastic hinges. Even at point D, we have a moment contribution. So, because the moment is not equal to 0 here. So let's do MU, MU, MU. So we're going to do 2 MU theta plus 1 MU theta plus 3 MU theta, so 6 MU theta, now equate the internal and external work. And rearrange for P, collapse load, at between C and D of the structure. So 6 MU theta over 8L. So 0.75 MU over P. So now we have the 3 collapse mechanisms and the 3 collapse loads.